All right, this is the other half of the question asking for this graph. There's finding acceleration time and there's also finding distance versus time. So now we're going to do distance versus time finding area. So remember, if we're doing velocity versus time and then distance versus time, we're going this way, we're finding area. Okay, we go the opposite way, we use slope. Okay, all right, so again, pause for a second, press pause on your video, try this, and then come back to check your answer. Okay, so let's go over the answer here. We're gonna be looking at area. So I still have my work from slope. We don't have to worry about that right now. Okay, so I want to take this. It's always area against the zero. Don't worry about the extremes here. So I'm going to try to look at these different regions, okay, and find the area for each one and then do a running total. Okay, so the area here is just going to be 2 times 1. So I'm just going to do base times height because it's a rectangle. So it's going to be 2 times -1. Okay. So that's my first area. That is this area. Okay, is -2. All right. So rather than plotting this each point, let me give all the points now, and then we'll look at the plot. Okay, so my next area is right here. So in this case, area is going to be 1/2 base times height because we have a triangle. It is 1 times 1. Okay, so they went backwards 2 meters and now they've gone backwards another 1/2 meter. Okay, they've hit the 0 line, which means they're crossing directions. They went from slowing down to going forward and accelerating forward. Okay, so now we're going to find our next area here for this triangle. It's going to be the same equation. Okay, only now it went over 2 and up 2. So now they've gone forward another 2 meters. Okay, and then we'll just keep plugging away here. My next area, okay, it's a rectangle again. Okay, and it went over 1 and up 2. Okay, and then finally we have the last triangle here. Okay, and again, these are, even though it's moving down, it's slowing down, it's slowing down while traveling forward, and we know that because it's above the 0 mark. So anything above here is all forward motion, anything below here is all backwards motion. Okay, so what we're looking at, this is still forward motion slowing down, so it's all positive numbers, which is the important part. Okay, so now we have a series of points that we can start doing a running total with. Okay, so those are going to be the things that we look at as we come across our graph here. Okay, all right, so if then again, they would have to tell you the point where do you start at. So let's assume we start at 0, 0, but the shape will remain constant. If they give you a different starting point, you're just going to shift this up and down. Okay. So let's take a look at how do we graph this. Okay. So we're going to start at 0 and we're going to go backwards 2. Okay. All right. And then we're going to go back another 1/2. And now we're going to go up 2 more. Okay, so notice when we crossed 0, we went from going down to going up. So now we're at, this was, where can I put my points here? 2, -2. This was 3, -2.5. Okay, try and get everything to fit on here. All right, and then if you can see it, it is going up 2 here. So I was at -2.5. So at 5 seconds, I'm going to be at -0.5. Okay, so this is going to be 5, -0.5. Okay, and then I'm going to go up 2 more. Okay, in case you couldn't see that, this was 2 meters, this square here. So in the next 1 second, I'm going to go up 2 more. Okay, so this was 6 and 1.5. And then I'm still in the positive zone. I'm still moving up. I'm moving up 1 more. Okay, so now I'm at 7 and 2.5. Okay, so we found our areas. We plotted our points. So the last thing to think about is the curve and the curve of these lines. Okay, so this was a constant. This is -1, -1, -1, -1, which means that if going from here to here is slope, that means this has the same slope. An object that has the same slope is called a line. Okay, so this is going to be a line from here to here. Now my slope approaches 0. So it's no longer going to be a line. It is going to curve until it hits 0. Now my slope is going to get more and more positive. Okay, so now I need this to curve upwards until it hits that one. So it should be a curve, and it looks like I overcurved it, in fact. Because here, once again, we have a straight line. So that means the slope does not change, which means this is going to be a straight line. Well, that came out pretty well. Okay, and then finally, 1 more curve. And where does the slope of that last curve end? It ends at 0. Okay, so this needs to curve until it ends at 0. Okay, so this is going to be your distance versus time graph.